Yes, hello Abhinav, welcome on UPDA platform and let's start your snap for your
Yes, sir.
ONGC interview. As you mentioned, you are having your interview on 11th of January for ONGC and today
Yes,
you
sir.
want thermodynamic snap.
Yes, sir.
So Abhinav, my first question is to you, what is calorific value?
Sir, calorific value is defined for a fuel. How much heat it can be generated when it is burned.
Mhm.
Yes, sir.
आपने प्रिंसिपल ऑफ कैलोरीमेट्री सुना है? You heard about principle of calorimetry?
Uh, Sir, I have heard about it, but I'm not sure about it.
Okay. So what do you understand by pure substances?
Pure substances are defined on the basis of a few parameters. Like they should be chemically homogeneous and mechanically separable. Yes, sir.
Which particular device instrument we use to measure the calorific value of liquid and solid fuels?
Sir, I'm not sure about it.
You heard about bomb calorimeter?
Yes, sir. I have heard about it, but I have not read
So
about
how
it
it works
recently.
that you don't know?
No, sir, not right now.
Fine. अच्छा, isoporic processes क्या होते हैं? What are isoporic processes?
Sir, which in those processes, the volume remains constant.
कोई example दे सकते हो? Can you give me one example of isoporic process?
Uh, uh, any process in which, like in a fixed container, a rigid container.
Rigid container में जो process होगी that will be isoporic.
Yes, sir.
What about isobaric?
Isobaric processes have the process pressure as constant.
Just give me one example of isobaric also. Isobaric, isothermal, adiabatic.
Sir, isobaric will be when piston cylinder arrangement, the piston is free to move, subjected to the atmospheric pressure on the other side. And
What about isothermal?
isothermal process will be any process that involves like a phase change.
That involves phase change.
Yes, sir.
So phase changes processes are isothermal.
Yes, sir.
During phase change, pressure also remain constant.
Yes, sir.
So isothermal processes are isothermal as well as isobaric.
So not always. In a phase change process, the temperature as well the pressure remains constant, equal to saturation temperature and saturation pressure. And isothermal process can also be other processes, like if in a piston cylinder arrangement, we are
You heard
adding
about
a.
Molier chart, Molier diagram.
Yes, sir.
क्या होता है?
So it is a graph between the enthalpy of a substance and the entropy of a substance.
Can you define these two quantities, enthalpy and entropy?
Yes, sir. Sir, enthalpy is can be easily defined as the internal energy of a moving fluid. In numerical values, it can be defined as H is equal to U plus PV. That is internal energy plus the amount of work that it requires to be in flow. And entropy can be defined as it is basically an abstract quantity that is defined to define the direction of natural processes or any other process for that matter. That why
Can
does
you draw constant pressure lines, isobaric lines on HS diagram?
Yes, sir.
This is true.
Sir, is it visible, sir?
Okay. I got the idea. Yes, fine.
Yes, sir.
You are showing some diversion actually in the
Yes, sir.
superheat region. Why?
Sir, because the slope of the isobaric lines on a HS diagram denotes temperature. So as temperature is increasing on the right side, as we are moving on the right side of the graph.
Fine. What about isothermal lines on HS diagram? Can you show isothermal lines also?
Yes, sir.
Just go ahead. Put it slightly. I think you focused. Your camera is focusing. Put it slightly, away from the camera.
Or I think it
No.
is some kind.
Yes, yes. It is visible, but not
So
very clear. Okay.
inside the dome, the both of the isobaric and isothermal lines will be same. Outside the
What
dome,
about in the superheat region?
the temperature lines will be different from the isobaric lines and have slope lesser than that of them.
Slope less than that. Why?
Uh, Sir, I'm not sure, but that is how I remember it. That the isothermal lines have lesser slope as compared to isobaric lines in the superheated region.
Hmm. Okay.
Yes.
Abhinav, what is second law of thermodynamics?
The second law of thermodynamics, in simpler terms, is like the entropy of the universe is always increasing. Other than that, there is like Kelvin Planck statement and Closure statement also.
Hmm.
Yes, sir.
Okay. What is Carnot theorem? Can you tell me something about Carnot theorem?
Carnot theorem. Yes, sir. Like the second law tells us that the efficiency can never be 100%. Some heat has to be rejected when we are converting heat to work. So the Carnot theorem defines that the efficiency of the reversible engine will be the highest. To define the maximum efficiency, it has to be that of a reversible engine, and all other engines have efficiencies lesser than that. And also that all the reversible engines will have the same efficiency.
Then how we can have a reversible engine? You heard about Stirling engine, Stirling cycle.
Stirling engine, yes, sir.
Can you draw that Stirling cycle?
Yes, sir.
That cycle is a reversible cycle or irreversible cycle? When I'm not visible, I think you're.
Sir, can I explain it? Sir, it is same as Otto cycle,
I think
but
you
instead
removed
of
your background, na? That's why it is focusing on. Not capturing that. Camera is not capturing the picture. Fine, fine. Okay, Abhinav.
sir, it is same as Otto cycle. Instead of adiabatic processes of expansion and compression, there are isothermal process of compression and.
So, what do you understand by a reversible cycle?
The reversible cycle is that cycle which does not involve any internal or external irreversibilities. Internal reversibilities are just generated because of some internal processes. External irreversibilities include temperature gradient, friction, all these things.
What is available energy?
But available energy is the maximum amount of energy that can be obtained during a process, and that occurs when the process occurs in a reversible manner.
Okay. You heard about Clausius-Clapeyron equation. What is the use of that equation in thermodynamics?
So that equation is
Clausius-Clapeyron equations.
Yes, sir. So that equation is used to, find out either the saturation temperature or pressure, and it can also be used to find out enthalpy, HFG value.
So HFG is a kind of constant, or it changes with temperature, pressure?
Sir, it changes depending on different saturation temperature and pressures.
What is critical point?
Critical point is that point where we cannot differentiate between the liquid and vapor, and below which liquid cannot exist.
Below critical point, liquid cannot exist.
No, sir. Wait a second.
Or above critical point.
Above critical point, liquid cannot exist. And on the critical point, it is impossible to differentiate between liquid and vapor of any pure substance.
My one more question to you, Abhinav.
Yes, sir.
There is some thermodynamic temperature scale. You heard thermodynamic temperature scale?
Yes, sir.
What is that?
That is the Kelvin scale, basically. It is based on a single point of reference, whereas all other temperature scales are based on 2 points of reference. That is the steam point and ice point. But this scale is based on single point of reference, which is the triple point of water.
What do you understand by reference state, and which particular state we take as a reference state in steam table?
Sir, usually it is taken as the triple point, where the enthalpy and enthalpy change and entropy change are taken to be 0. Entropy value, sorry, not change.
So enthalpy is 0 at triple point.
Yes, sir. On steam table, it is taken as 0.
You observed it 0.
Sir, as far as I can remember, for reference, it is taken to be 0 because
if it is 0, then enthalpy is U plus PV.
Yes, sir.
So it means PV is 0.
No, sir. Sir, actually, we are not actually concerned with the actual values of enthalpy and entropy. We are concerned about the change only.
Fine. Okay, Abhinav, I think now I can provide the feedback. Abhinav, your way of answering is looking fine. You are looking comfortable. I feel that is fine, good. Yes, you have not answered some of the question. Like I asked you about calorimeter, principle of calorimetry. So principle of calorimetry is nothing but what? Conservation of energy. If there are two bodies exchanging heat, the heat lost by one of the body will be equal to the heat gained by other. Or two bodies if you are having and you are mixing them, then the energy content of the mixture will be the energy content of first body plus energy content of the second body. So it is nothing but the principle of energy balance, conservation of energy. Okay, principle of calorimetry.
Okay, sir.
थोड़ा सा bomb calorimeter के बारे में पढ़ना and how it works, what process we can observe in that bomb calorimeter and how we use it to measure the calorific value.
Okay, sir.
Then I asked you about some examples related to isoporic, isothermal, isobaric. So those you answered. I think adiabatic you missed. Adiabatic process will be what, like when there will be no heat transfer. So if a process is very, very fast, it's the first case, like the free expansion, that is an adiabatic process. Or second case, if the area of the device is very, very less, like in case of throttling, that can also be considered as adiabatic process. Third case, if the device is fully insulated.
Yes, sir.
If the body is insulated, the area is very less, or the process is very, very fast. In all these three cases, we can consider the process as an adiabatic process.
Yes, sir.
Isothermal means you are adding heat without any difference of temperature. Means the source and the body where you are adding heat both are at same temperature.
Yes, sir.
Then I asked you about reversible cycle. So cycle, yes, a cycle is known as reversible cycle if it is not bringing any change into the surroundings.
Yes, sir.
Okay, so net entropy generation in the cycle will be 0 for both system and surrounding. For any of the cycle, whether it is reversible or irreversible, entropy change of the system will be 0.
Yes,
because you are bringing the system to the same initial condition. But what about entropy change of surrounding? That is going to increase if you are having an irreversible cycle. But if you are having a reversible cycle, entropy change will be 0. You can prove it very easily using the Carnot theorem. So during Carnot cycle, the entropy change of system is 0. What about surrounding? Surrounding entropy is going to decrease when you are taking heat. That will be minus Q1 by T1. But again, you are rejecting heat into the surrounding. That will be Q2 T2. But Q1 T1 equal to Q2 T2. One is positive, another one is negative. It means the net entropy change of the surrounding is also 0. Are you getting it?
So in a reversible process, entropy change of the universe should be 0. System can increase or
Yes,
decrease.
entropy change of universe should be 0. Yes. System
can
entropy can
change.
increase or decrease. Surrounding
Yes, sir.
entropy can increase or decrease.
Yes, sir.
But their collective entropy change will be 0 if you are having a reversible process or a reversible
Yes.
cycle. Go
Yes,
to the
sir.
point.
Yes, sir.
Clausius-Clapeyron equation, I asked, yes, some of the points you highlight. That equation actually gives us the relationship between P saturation and T saturation. How
Yes,
the
sir.
pressure, saturation pressure varies with the saturation temperature.
Yes, sir.
तो ठीक है, मेरे को ठीक लगा अभिनव. थर्मोडायनेमिक टेम्परेचर्स के लिए जो होता है ना Q by T1, इसी को बोलते हैं Q1 by T1 that is equal to Q2 by T2, means you can represent temperature in terms of the heat. If you observe that equation, Q1 by T1 equal to Q2 by T2, so in that equation temperature you can find out. Suppose if you take one temperature T1 as a known standard
Yes, sir.
temperature, T2 is unknown, so you can easily define T2 in terms of heat. Actually heat is not a property. Heat is
Yes,
not a
sir.
property, but in that thermodynamic temperature scale, why actually we are saying that is a scale Q1 by T1 equal to Q2 by T2, because we can define temperature in terms of heat. So
Yes,
heat
sir.
is a thermometric property in that scale. Are you getting?
Yes, sir. Yes, sir.
So T1 by Q1 will be what? Q1 by T1 will be some standard Q and standard T.
Yes,
So by
sir.
measuring Q, you can define T.
Yes, yes, sir.
Some more things you mentioned about the absolute temperature scale, Kelvin scale. That those things are fine. Huh?
Yes,
ठीक
sir.
है, मेरे को ठीक लगा. Actually, in interview, it doesn't matter a lot like how much question you answer. It matters how actually you are facing all those questions. So that's why I am satisfied with your performance, because
Yes, sir. Sir, is
some of
it
the
okay
question you
for
missed, but very
ONGC level?
confidently you yes
Yes,
very
sir.
confidently you mentioned, "Ki, sir, I don't know about that answer." So you have not tried to bluff with the with that particular question, and even you have not wrongly answered that question. So those are good things. So I
Yes,
feel if
sir.
you go into some more detail, and then you will be able to get some more concept related to this subject, and you will be able to improve your further performance. This time it's okay, good. Again,
Okay, sir.
watch the marathon class, listen to some of the snaps, and if you face any kind of technical doubt query, you can reach to me. Okay.
Okay, sir. Okay.
Okay, Abhinav, good luck.
Thank you, sir. Thank you.